I'm just going to finish up with selected homework problems from section 4.1a, finding indefinite integrals. So 31, 33, 43, and 45. Okay. 31, we want to combine these y's together so that we can apply power rule. So if I have to first rewrite the square root of y as y to the 1/2. Next, we see that if we want to multiply like bases, I can add exponents. So 2 plus 1/2 is the same thing as 4/2 plus 1/2, which is 5/2. So once I have my variable raised to the rational exponent, it is in the right place. It's already in the numerator, and we just apply the power rule. So 5/2 plus 1, 5/2 plus 2 over 2 is 7/2. Okay. Flip, bring the 2/7 up to the, get it out of complex fraction, and we get 2/7 y to the 7/2 plus c, or 2 square root of y to the 7th over 7 plus c. Okay. 33, simply we have a constant, and if we have integral of a constant, then the indefinite integral is simply the constant times x plus c. All right, 43, we want to graph. We have a graph of the derivative function given. Sketch the graph of two functions that have the given derivative. Okay, so we're given f prime. We want to be able to graph two f of x functions. So if we look at this, remember, if you're looking at f prime graph, all your y values represent slope. So we want a graph that has a constant slope of 2. Okay. If we want to think of it in terms of integral, we can think of it as if we want to find the integral of 2, it will simply be 2x plus c. And that's essentially what we're graphing, right? We want to graph lines that have a constant slope of 2, but we can choose two separate, we can create these two functions by giving it two separate y-intercepts. So if I have a y-intercept at 2, I can make the graph y equals 2x plus 2. This has a slope of 2 over 1 for any point on the graph. And now I can also have 2x minus 3, where I have 2x, a graph of a slope of 2, but my y-intercept being negative 3. So you're always going to get parallel lines if you want two graphs with the same slope and different y-intercepts. These are just examples. I could have another graph that is simply y equals 2x plus 0, right through the origin. Okay, 45. Okay. Having the ability to sketch your original function given your f prime. So if your f prime is a parabola, then we know that anything above the x-axis represents positive slope, anything below the x-axis represents negative slope. So we see that the graph has a negative slope, followed by a positive slope, followed by a negative slope. Okay, so actually, based off of this, we can create our sine line. All right, and we know that the graph will reach slope of 0 at negative 1 and 1. Below the x-axis, we know the graph will be decreasing. Between negative 1 and 1, we know the graph is increasing. And to the right of 1, we know the graph is decreasing. Okay. So we can also think of it in terms of calculus. If f prime is 1 minus x squared, then the integral is simply 1 minus x squared applying the power rule. So 1 becomes x, x squared becomes x cubed over 3 plus c. So we have a graph that has this general characteristic. And we can also sketch a graph based off of the sine line. Right? Decreasing slope hits a minimum at negative 1, increases, hits a maximum at 1, decreases. Okay? And we can choose to have this anywhere on the y-axis, but your shape is always going to be the same. Your graphs will share the same slopes throughout, corresponding slopes throughout, but it'll just be in different location in terms of y-intercept.